Oh, gravity, you heartless so-and-so. Well, that's what I think when I trip over a stone and fall face down. Of course, I'm not clumsy, you know. Anyway, gravity is a constant, right? Something entirely unshakable that we can always rely on in this ever-changing world. Unlike, love. Feeling romantic, sorry. But what if I told you that it's not as honest and clear as you think? There are places on our planet where gravity behaves like it's gone crazy. And that's why you clicked here. So let's take a look. Magnetic Hill in Leh, India. There's a stretch of road in India that's been attracting tourists from all over the world. It's no different looking from the surrounding landscape, and you could easily pass it by without noticing, if not for one very unusual and a bit creepy thing. If you stop your car on the magnetic hill going up the slope and put it on neutral, it'll start crawling upwards, eventually reaching the speed of up to 12 miles per hour. They say there's some sort of magnetic force at work here that tugs cars up the hill, hence the name. On top of that, even airplanes are said to gain altitude above this place. Skeptics offer another explanation, though. It's just the lay of the land that creates an illusion of going upwards, while in fact you're moving down the hill and vice versa. Whatever the truth, I'd like to see it for myself. Would you? Tell me down in the comments. The Crooked Forest, Poland. Near the village of Nowa Charnowo, there's a forest in the depth of which you can find a strangely looking pine tree. Planted in the 1930s, there are 400 trees that sharply twist to the north almost at the roots, and then grow upwards in a semicircle. Although scientists offer different theories about the tree's weird growth, nobody can say for sure what made them look like that. Some say it's people who did it, while others believe it's a gravitational anomaly that somehow pushed the trees down. The trouble with this version, though, is that it would have had to stay there for years, and that only affected the trees. Still, no certain explanation exists anyways, so who knows? A waterfall, Faroe Islands. Ever seen an upward-moving waterfall? You can have a look at one on the Faroe Islands, halfway from Iceland to Scotland. But if you were expecting me to tell you an unbelievable story about a mysterious force pushing the water up the rock, then sorry, no such thing here. The truth, however, is quite jaw-dropping anyway. The winds in this place are so powerful that they lift the water and throw it back up. I guess it was this kind of wind that allowed Mary Poppins to travel on her umbrella. Sounds good. In fact, this waterfall is not unique. There are several more places on Earth where winds create an illusion of defied gravity. For example, there's the Kinder River in England that has a waterfall constantly struggling with the wind. It's so strong that half of the Cascades water seems to just fly up without ever touching the bottom of the drop. Hoover Dam in Nevada, USA. If you ever get up to the top of the dam, which is about 726 feet high, you can try a little trick. Take a bottle of water and pour it over the edge. You'll see the water flow up instead of spilling down. Once again, this isn't really any magic or unnatural phenomenon. The wind up here is simply too strong for the water to fall, just like with the waterfall on the Faroe Islands. Here though, it looks even more impressive since you can do it yourself. Dokkaebi Road, South Korea. Another gravitational anomaly located on a road. Locals once found out that if you put an empty can or a bottle on the ground, it will immediately start rolling uphill. Unlike other such places in the world though, Dokkaebi Road doesn't just create an illusion. When you walk down the slope, you don't feel as if you're going up. Everything's pretty normal. But once you put down an object that can roll, it will do that in the opposite direction than it should. Local authorities were quick to get the idea and put a signpost directing curious tourists to the mysterious road. Golden Rock, Burma. If you happen to be in Burma, these days it's also called Myanmar, make sure to visit this well-known site. A gold leaf-covered boulder sits upon the edge of a cliff, and a small pagoda is built on top of it. The impressive thing about the rock is that it only lightly touches the cliff for support. In fact, it looks like the boulder will fall any minute now. but it has been standing like that for centuries. On top of that, the pagoda built upon it is not really a recent addition, so it's quite an unusual sight to see. The rock seems to be saying, "Gravity? I don't care about that stuff." The legend has it that what keeps the boulder in place is a single strand of Buddha's hair. Well, I don't know about that, but you can check out the rock for yourself and see that it's not attached to the cliff by anything. And yet, it's not budged for 2,500 years. Something must be at work here, huh? Stone of Davasco, Argentina. If there ever was a thing that said, "I defy gravity" out loud, it's the Stone of Davasco. The huge 300-ton boulder stands precariously on the edge of a cliff and rocks a little bit from side to side in the wind. People even checked it by putting glass bottles under one of its edges. They exploded with another movement of the rock. Unfortunately, today you can't see this wonder of nature as it was a century ago. In 1912, the boulder suddenly dropped from its perch, which it had occupied for literally hundreds of years. The people in the nearby town of Tandil were so sad about this event that 95 years later, in 2007, they decided to restore the stone. Well, not exactly put it together chip by chip. They made a plastic replica of the rock and put it on the same spot and even in the same position. So even today, coming by Tandil, you can see its famous balancing boulder. More of a symbol now, of course, because it's no longer rocking and only weighs 9 tons, but instantly recognizable nonetheless. Devil's Tower in Wyoming, USA. Remember this place from the movie Close Encounters of the Third Kind? If not, you should go watch it, but not right now. This place doesn't make you feel like you're witnessing some magic and doesn't really trick gravity right before your eyes. Sounds almost boring compared with the rest of the sites on my list, right? But the true mind-blowing feature of Devil's Tower is that scientists can't explain how it came to existence in the first place. You see, it's an 867-foot rock formation with walls so steep they're basically vertical. But that isn't even the main thing. This piece of stone just rose amid rolling plains of Wyoming with nothing like it for miles and miles around. So how is it that such a flat landscape could have suddenly given birth to something so tall? Theories abound, but nobody has the answer yet. My theory? Well, perhaps here is where the Earth has a giant outie belly button. Well then, you come up with a better theory. Oregon Vortex, USA. The House of Mystery in Gold Hill, Oregon amazes its visitors with gravity-defying effects. You can't stand straight there, always leaning to the side and having to hold on to something for balance. Balls roll upwards. And there's also a broom that stands perfectly still wherever you put it, unlike virtually everything else in this shack. The local Native American tribes called this place the Forbidden Ground, even before the house was built there, and they avoided approaching it. The owners of the shack, though, decided to turn it into an attraction, and they succeeded. They created an atmosphere of mystery around the place and spread the news about it in newspapers and later on the internet, and voila, a perfect anomaly is made. In fact, it's no more than a curiosity, a human-made optical illusion that tricks your eyes and other senses. Hudson Bay, Canada. Okay, we've talked about some pretty ambiguous stuff, but now it's time for the real deal, the Hudson Bay anomaly. This is probably the only place in the world where gravity is indeed lower than anywhere else on the planet. Even skeptics can't smirk at it because the difference has been measured with precision equipment. So, does it mean that the gravity here is as low as, say, on the moon then? Unfortunately, or is it luckily, I'm not sure yet, the difference is minuscule. The exact value is 0.005%, or 1/200%. You won't be able to feel it even if you try your hardest, but it's still there. Scientists say this anomaly exists because of the ice sheet that covered the area about 10,000 years ago. It compressed the rocks so much that they still can't fully recover, shifting the gravitational field in Hudson Bay. Sometime in the future, though, the gravity will return to normal in this area as well. No moonwalk for me then.
You might not think about gravity much, but it affects everything we do. It's the reason why things fall down instead of flying up. It keeps us connected to the Earth, so we don't float away into space when we jump. But for physicists, gravity is something more. It's a fascinating puzzle that needs to be solved to understand how the universe works, and they're on a quest to uncover its secrets. So what's so mysterious about it? Let's see. We've learned a lot about gravity from the legendary Isaac Newton. He was the first to invent the law of gravitation. He taught us that any two objects in the universe can't help but be attracted to each other. It's like they have this secret gravitational crush going on. How strong this attraction is depends on two things: how big the objects are, that is their mass, and how close they are to each other. But here's where it gets cool. Gravity isn't just a two-object dance. It's a complex space choreography. Take our solar system, for example. The sun plays the lead role, using its gravitational pull to keep all the planets in their orbits. But each planet also has its own gravitational mojo, tugging at the sun and even its neighboring planets. Then, a few hundred years later, another hero, Albert Einstein, took gravity to a whole new level. He described the theory of general relativity. According to Einstein, gravity isn't just a regular force. In reality, it's curving and warping the fabric of space-time. Think of it as a heavyweight champion sitting on a rubber sheet. The sheet bends and curves under the weight, and the smaller objects nearby can't help but roll towards the heavyweight. Now, even though we can't see space's curves with our own eyes, we can see what happens to objects that get caught in its grasp. Getting pulled by gravity is like being caught in a whirlwind of forces. The caught object starts spiraling downward, just like a coin in those penny slot cyclone machines you find at tourist shops. Or it might move gracefully in circles, like bicycles racing around a velodrome track. Gravity is the primordial force that guides our entire world. Without it, there would be no stars, no galaxies, nothing. But where does it come from? Well, that's the million-dollar question. And we don't have a complete answer just yet. But we do have some guesses. First of all, we know that gravity is more than just a feature of space. It's a force that pulls things together. Surprisingly, it's the weakest force among them all. But let's take a different look at gravity. Something that may surprise you. Instead of being a force that directly pushes or pulls objects from a distance, it's more like a dance. Gravity, as amazing as it is, doesn't perform alone in this dance. It shares the spotlight with other forces, like electromagnetism, for example. Let's imagine two electrons. There are dancers. Now, they don't directly push or pull each other like you might expect. Instead, one electron creates a special kind of field around itself, like an invisible force field. This field sets the stage for the show. The other electron senses this field and starts to twirl and interact with it. It's like they're following some choreography. And when we watch this dance, it looks as if the second electron is being pushed or pulled by the first one. But in reality, it's all about the intricate movements and interplay between the dancers and the field they're dancing in. The dancers never touch each other directly, but their interactions through these fields make it seem like they're connected. It's a magical display of fields and movements coming together to create the illusion of forces at play. The thing we call gravity. So even though it's not a force in the usual way, it behaves like one. We call it an emergent force, because it emerges or comes out from the way space and objects interact. Which is why, if we want to get technical, some scientists prefer to avoid the words gravitational force and opt for the term interaction. It's just a way for particles to mingle and exchange energy and information. Electromagnetic interactions, gravitational interactions, they're all part of this grand soiree. At least that's one of the theories. Some scientists also think that gravity might be made up of tiny particles called gravitons. These sneaky particles work behind the scenes, making objects attract each other. However, we haven't been able to directly see these elusive gravitons yet. So, according to this theory, gravity is both a force and a potential particle. As you can see, we have some struggles with explaining how gravity works on a large scale. But at least we have a good understanding of how it behaves in certain situations, like how planets orbit the sun, or how objects fall to the ground and stuff. But what happens when we zoom into the atomic scale? And what if we venture into the depths of black holes and the Big Bang? Now here's where gravity's wild ride goes off the rails. First, let's enter the realm of quantum mechanics. There's something peculiar that happens in this tiny world. Gravity, the force that pulls things together, seems to take a back seat. On a microscopic scale, other forces like electromagnetism take the spotlight and become the superstars. They're overshadowing gravity, and this leaves scientists scratching their heads, wondering, is this possible? Why does gravity suddenly fade away? So far, we have no idea. And when it comes to the grandest scales, where immense objects like black holes, gravity takes on a whole new level of complexity. For example, inside a black hole, laws of physics and gravity, as we know them, basically fall apart. It also decays when we try to understand how gravity behaved immediately after the Big Bang. Where did it even come from? We have no idea. In other words, we find ourselves in a cosmic fog when it comes to understanding gravity. But fear not, scientists are working hard to learn more about this enigmatic, emergent force. They're doing all sorts of experiments and using fancy technology to crack its code. Even though we still have a lot to figure out, we're making progress every day. For example, have you ever heard of gravitational lensing? It's like a mesmerizing magic trick. Imagine a beam of light as a fearless explorer, taking a straight path through the universe. But as it encounters the gravitational pull of a massive object, the light's journey becomes a wild roller coaster ride. The gravity of the massive object bends the fabric of space-time, creating a funhouse mirror effect. Our brave beam of light finds itself curving and twisting around the massive object, following a new, unexpected path. But as the light changes its trajectory, it also reveals to us distant and hidden wonders that would have remained invisible otherwise. The light can magnify, distort, or even create multiple images of faraway objects. So all the things that have been playing hide and seek with us finally become visible, like black holes. There's also a mind-blowing idea called gravitational waves. Einstein predicted their existence tens of years ago, but only recently have we finally been able to confirm them. And that was a huge breakthrough in the science world. These waves carry the echoes of cataclysmic cosmic events, such as the collision of massive black holes or the birth of newborn stars. Just like dropping a pebble into a serene pond, these crazy events cause a ripple effect. But instead of water, it's space-time itself that ripples and warps. Scientists have just recently developed a way to listen to these whispers. They've created instruments capable of detecting these gravitational waves. These instruments, known as interferometers, are like ears that are finely tuned to catch the subtle vibrations of the universe. But one thing's for sure, gravity is a superstar that shapes our universe. It keeps everything around us connected and rules our entire universe. The quest to unveil its ultimate secrets continues, and it's a thrilling adventure for scientists and curious minds alike. Picture this. You're in a cozy spot, away from city light pollution, staring up at billions of stars putting on a sparkling show above you. But if you're lucky enough to be in Marfa, Texas, you'll get a little something extra. Mysterious orbs decide to join in on the fun, shining bright like a diamond, and they've been doing it for over 100 years. But what are these glowing orbs called Marfa lights? Well, everyone has their own theories. Some people think they're just car lights from the nearby highway, but that's no fun. Others believe that these orbs are actually sentient beings trying to convey some sort of important message to us, mere mortals. Imagine standing at the edge of a stunning lake, admiring the picturesque view of a majestic volcano. Suddenly, you hear a loud boom and flames shoot up into the air like a fireworks show gone wild. But don't worry, it's not an eruption, it's just the Kauai'an Lake and volcano doing its thing. This fiery spectacle is caused by a natural phenomenon where sulfuric gases burst through the rocks and ignite upon contact with the outside air. The result? Flames that soar up to 16 feet in height, burning blue like the coolest neon lights you've ever seen. And if that's not enough, the liquid sulfur that streams down the mountain looks like a molten river of electric blue lava. It's equal parts terrifying and breathtaking, and a sight you won't soon forget. Speaking of unforgettable things, the Richat structure in Mauritania has been an eye-catching enigma for astronauts since the dawn of the NASA space program. This circular feature in Earth's crust was created by a raised dome that was eroded over time, revealing the original flat rock layers. As you move from the center of the structure outward, you travel back in time, as the older rock layers are exposed in the middle. This geological phenomenon is made up of sedimentary and igneous rocks and measures 28 miles across. From space, you can see several faults where the rock layers have shifted and have been pulled apart. The Ratchat structure is situated in the heart of the Sahara Desert. There you go. This is our version of the top 10. Would you add something else to this list?